Hey guys, we're gonna do the foldables, okay? So you don't have to do every single foldable. These are just, show us some class notes of some of these sample problems and you'll get your 10 points. I make the videos though in case some students are using it to study and they're wanting to check their answers. Okay, so arc lengths and circumference. So we use two formulas, 2 pi r and pi times diameter. Those are the two formulas for circumference, and essentially they're the same formula, right? Because if this is the radius, right, and we use the letter r to be short for radius, then its diameter is 2 radii, so the diameter is all the way across. So that's why instead of a diameter, you can substitute in a 2 and an r. It's the same equation. Nice. Okay, so example 1, it says find the circumference. So the circumference is pi times the diameter. So this is 7, so all the way across would be 2 7s. So the diameter would be 14. So the circumference is pi times 14. Now it says in our directions, just to be consistent, if you don't have a calculator with a pi button, like most of us don't, maybe that's not true, but if I go to some type of a calculator on my iPad here, then here it is, okay. I don't see a pi button. So they're saying just use 3.14 for pi. So 14 times 3.14 equals 43.96. 43.96. Now it doesn't say what to round to, so I'm not quite sure. I'll just, leave my answer that way, but it is in millimeters. And I can think about, does this make sense? So we talked in class, if all the way across is 14, then that's about 14. And that's about another 14, and that's about another 14. That's really what pi means, is that if this is 14, then there's a little bit more than 3 14s to get all the way around. And 14 times 3 is 42. Notice this is a little bit bigger than 42. So that's another way to know that we got the right answer. Now here they started off giving us the diameter is 5. So the circumference is pi times the diameter. So the circumference is pi times 5. Or 3.14 times 5. So checking with our calculator, 5 times 3.14. 15.7 feet. Example 2, now they're asking us to work the problem backwards. Oh, excuse me, I bumped that. And solve for the radius. So I'm going to use this first formula because it has r in it, right? So circumference is 2 pi r. So here we're given the circumference. We can plug that in for C. So we can write this 56.52 is 2 times pi times r. Now we talked about what we like to call a Lynch swap. Notice if I divide by 2 on both sides, that's the division property of equality from algebra, these would cancel, leaving us the r. And that's what we want to do, is get r by itself on one side. So in the end, the 2 pi come down here. So we've been working since trig to move this number down there to kind of cut out a lot of writing and make a shortcut. So 56.52, I can rewrite with the 2 pi down here, leaving r by itself. Now it's just a matter of typing in our calculator. So 56.52, divide by 2, divide by pi. 56.52, divide by 2 equals, divide by 3.14 equals, and I get 9. So my radius is 9, and that makes sense. If this is 9, all the way across is 18, and 318 times 3 is 54. Notice this number is a little bit bigger than 54. Here, same thing. We have our circumference, and we know it's equal to 2 pi r. So using the Lynch swap, we could move the 2 pi down, giving us r. So 25.12 divide by 2, enter, divide by pi, enter, 4. Okay, so if that's 4, all the way across is 8, and 3/8 is 24. So yep, that's a little bit bigger than 24. Example 5, it's exactly the same thing, only they just want the diameter. So I could do it the same way and then double this, right? Or I could use the other formula, and that's actually faster, so we'll do it that way. I could use the formula circumference is pi times the diameter. So the circumference, 6908, is equal to pi times the diameter. So using the Lynch swap to find the diameter, I just take my circumference and divide by pi. 6908, 6908. Oh boy, we got an add in here. Really? Let's go back here. 6908. 6908 divided by 3.14. We get 22. Right, this one, same thing. The circumference is 47.1. And if I divide by pi, I'll get the diameter. So 47.1 divided by pi. 15. And this is miles. 15 times 3 is 45. Yep, and that's a little bit bigger than 45. Now for arc length. So we review circumference when we do arc length because arc length is a portion of the circumference. So if the circumference is 2 pi r, notice it's just a portion of that. So this same fraction should make sense here if this angle, the measure of arc AB, is a portion of all the way around 360. That should be the same portion. For instance, we said in class, if this is a quarter of all the way around, then this has to be a quarter of the circle or of the circumference. So using this Lynch swap again, I can move this 2 pi r to the top and solve for the arc length. So the arc length is the measure of a arc AB times 2 pi r. We also really, mathematicians don't like to write that all out. So they use the letter S anytime they're solving for the arc length. So here they've asked us to solve for the length. So we'll say S is equal to the measure of the arc, 70. Out of 360, I'm using this formula right here, times 2 times pi times the radius 9. So I've got to put all that in my calculator. 70 divided by 360 times 2 times pi times r, which was 9. Okay, we get 10.99. Okay, and now B, same formula. S is equal to the ratio the angle makes, 120 over times the circumference, 2 pi and 3. So 120 over 360, 2 pi 3. .28. So for example 5, now instead of solving for the arc length here, they're asking us to solve for this measurement. So we're going to have to set up this same formula, but then do a little algebra magic, right? Probably move the 360 up here and the 2 pi r down below to get the measure of arc AB by itself. So S, our arc length, is equal to our angle, but that's what we're solving for, the measure of arc AB over 360 times 2 times pi times the radius 6. But here, notice they've given us S. So instead of the letter S, I should be able to substitute in this number. 5.75 is equal to this ratio. Okay, so we're going to move the 360 up here with the 5.75. And the 2 and the pi and the 6 down below. And we get the measure of arc AB by itself on one side. 360, 5.75. Times 2, or divide by 2, divide by pi. And the radius is 6. Divide by 6. So 54.93 or 4. It doesn't really say what to 54. I'm just going to say 54.9. So that's about 55 degrees. And I look up there and go, yeah, that's actually pretty, that looks about 50 degrees. If this were an equilateral triangle, it's close. That looks a little less than 60, and that's a little less than 60. Now, same thing. We take our arc length. We put it equal to the measure of that arc in a ratio with 360 times 2 pi, and our radius here is 10. So moving the 360 up with the 2268 and the 2 pi and 10 down, we should get our arc length. 2268. We multiply, divide by 2, divide by pi, divide by 10. 130, about 130, okay. So it's about 130 degrees. And we say, oh, okay, yeah, that's about 130 degrees. We know that a third of 360 is 120. So that's close to that angle. Example 6, now they're asking for the circumference. So we want to be reminded that, remember, this was or is our circumference. So we could also just put it back in the equation. The arc length is equal to the measure of an arc over 360 times your circumference. Right, so the arc length is equal to this angle, 80 over 360, times the circumference, and that's what we're solving for. So algebraically, if we can move the 360 up by the 57.5 and move the 80 down, we'll get our circumference. 360 times 57.5. Divide by 80. And yeah, I think that makes sense. 258.75 kilometer. If this is 60, okay, 1, 2, 3, 4, 5 or 6 60s. Yeah, so I'm looking for a number over 200. Okay, this is saying this arc length is 9.8 and our central angle is that. Can we solve? So we can say yes. The arc length, 9.8, is equal to this angle, 285 over 360 times your circumference. So you can multiply 360 on both sides, then divide by 285 and get your circumference. 360, 9.8, 285. I think I typed that in wrong. Yeah. Okay, I typed that in wrong, sorry. 360 times 9.8 divided by 285. Okay, so 12.38. And notice if this is 9 or 10, round up to 10, and that would be about 12. There you go. That is our first foldable arc length and circumference. Check out the next one.